All right, welcome to the Balancing Chemical Equations video. The first thing we're going to do is describe reactions and kind of show you how reactions are labeled. And this will be a review a little bit from what we talked about in our first video. But a chemical equation, which will show us a reaction, it uses symbols to describe a chemical reaction and show the relationship between the reactants and products of a reaction. So chemical equations show products and reactants. The reactants are on the left side of the arrow and the products are on the right side of the arrow. In a chemical equation, an arrow pointing to the right means yield or give. And chemical equations give chemists all over the world a common way to express chemical reactions. So they're kind of like SI units, how we use those, and those are worldwide. It's so we can compare data and talk with people around the world about the science that we're doing. All right, balanced chemical equations help us to account for the conservation of mass or matter. Remember when we talked about that mass cannot be created or destroyed? So that means a chemical equation has to have the same number of atoms on one side as it does the other side. So the reactant's mass has to equal the product's mass. Oh, this is what I just said. The mass of the reactants equal the mass of the products. So this is a chemical equation, okay? This is an example right here. Now let's look at this. Right here, this low number is a subscript, and we've already talked about subscripts. Remember, they flow or sit low like a submarine. And this 4 tells us we have 4 hydrogen. Since there is nothing after this carbon, that means we only have 1 carbon. And this 2 tells us we have 2 oxygen. So this is an unbalanced equation because we have 1 carbon here, 1 carbon here. That's balanced. But we have 4 hydrogen on the reactant side and only 2 on the products. That shows me it's not a balanced reaction. And then we also have 2 oxygen on the reactant side and 3, because we have 2 plus 1, 3 oxygen on the product side. So this is an unbalanced chemical equation, and we have to learn how to balance them so we can account for the conservation of mass and matter. Now the chemical equation above, it just tells us which compounds are involved in the reaction, but we don't know how many of each atom we will need yet because it's not balanced. Now, balanced chemical equations, again, account for the conservation of mass and matter. So when the number of atoms of each element on the right side of the equation matches the number of atoms of each element on the left side, that means the chemical equation is balanced. The chemical equation is balanced by adding coefficients in front of one or more of the formulas or elements. Coefficients are going to be numbers that go out front. You cannot change the subscripts, the small numbers at the bottom, but you can add a number out front, which is a coefficient. And coefficients are the only numbers you can change when you balance chemical equations. Now, steps to balancing chemical equations. We need to make sure that you have these written. If they're not already in your notes, make sure you write them in your notes. And coefficients are the numbers that can go right here in front of an element or a compound, all right? And we'll work with those in just a moment. Number 1, you list the elements on each side. Step 2, you count the atoms on each side. Step 3, you pick one element to balance. And then step 4, you recount all the atoms. Now, if you're not balanced after step 4, you repeat steps 3 and 4 until you become balanced. Now, let's go ahead and practice one of these. All right, the first thing it says to do is list the elements on each side. So right underneath the arrow, we're going to list each element that we have. We have carbon on both sides, we have hydrogen on both sides, and we have oxygen. Now, just a little hint. If you have carbon on the reactant side, you're going to have it on the product. So whatever elements you have on the reactants, you're always going to have on the products. Now it says count the atoms on each side. So we're going to go to the left side of carbon and count how many atoms we've got. We have 1. And we're going to go to the right side of carbon and count how many atoms we have over on the product side, and we have 1 carbon. Remember, I just have a C on each one of those, and whenever you don't have a number after the letter, that means you only have 1 of them because the 1 is understood. Now let's count our hydrogens on the reactant side. We have 4. Our hydrogens on the product side, we have 2. And then our oxygen on the reactants, we have 2. Oxygen on the products, we have 3. Now, the next thing is you pick one element to balance. Do you see how oxygen has 3 and 2? That is a very difficult element to balance at first, and sometimes it works itself out in the end. So always choose something easier to balance. And I'm going to tell you that you always can only multiply to make things balance. That's the only thing you can do. So on this hydrogen, I can actually say times 2, and that will equal 4. Right? So I do my times 2, and if I multiply the hydrogen on the product side by 2 on my list, I have to also multiply it up here. So this 2 and this 2 go to get, since I multiplied by 2 down here, I have to multiply by 2 up here. Now, step number 4 says recount all of the atoms. So let's make sure we recount all of them. So carbon on this side has 1 still, and carbon on this side also has 1. So they stayed the same. Hydrogen on the reactant side has 4. It didn't change. But the hydrogen on this side, see the 2 on the outside is kind of like distributive properties in math. You're going to say 2 times 2 hydrogen equals 4 hydrogen. So my oxygen also changed because it's in front of this compound. So 2 times 1 oxygen actually means I now have 4 oxygen on that side because I have 2 oxygen here and 2 oxygen here. All right? So let me just show you real quick about this coefficient. Now this red 2 is a coefficient, what we were talking like earlier. And if you'll think of the element or the compound being in parentheses and using distributive properties to multiply, that's what I was talking about earlier, about multiplying that 2 out as a distributive property. Now, let's go ahead and look back and finish balancing, or see if we're finished. So now I have 1 carbon, that's balanced. I have 4 hydrogen, that's balanced. But I have 2 oxygen and 4 oxygen. So how can I balance the oxygen to equal? What I have to do is I can multiply this side by 2. And if I multiply it in the list, I have to make sure I multiply it up here. So I multiply the oxygen by 2 on my list and in my formula. So now let's recount our atoms. Carbon on the reactant side stayed 1. Carbon on the products stayed 1. Hydrogen on the reactant stayed 4. Hydrogen on the product stayed 4. Oxygen on the reactant side changed because if I have 2 O2s, that means I have 4. So now this equals 4 oxygen. And then my oxygen on my product side is also 4. So now my equation is balanced. Okay, now guys, you have something in your notes that said label the coefficient and the subscript below. Circle the one that can change when balancing equations. So pause the video, go ahead and answer these questions, and then resume to see the answers. All right, this right here is the coefficient. And this right here is the subscript. And then it said circle the one that can change. The coefficient is what can change when you're balancing equations, not the subscript. All right, guys, go ahead and answer this question because it's in your notes. Which of the following equations are not balanced? And what I'd like you to do is circle each one that is not, pause the video, and resume the video once you're ready to find out the answers. All right, the equation that is not balanced is C. A, B, and D are actually all balanced. This concludes our video for balancing equations. So you still have some practice left in your notes. If you'd like to try those, that's fine, but we will work on those in class, so don't feel like you have to. And to go ahead and summarize for this section, I would like you to do this. I would like you to compare balancing equations to something in your everyday life and write about it, and then you're going to tell us about it tomorrow in class. So I hope you have a great evening, and I'll see you in class.